Hello once again on this St. Patrick's Day 2021, and this is going to be a video about some lovely lambda line lumping. Specifically, I'm going to be taking the techniques I use here for my beloved Figlet, which gives me really big headlines when I need them. And I'm going to be applying it to some of the functions that are calling out for it here. They're a little bit ugly, as requiring 2 lines between them because of PEP8 and having not even a body of the function so much as just returning the output. So these are extremely simple, like wrapper functions that don't even deserve 2 lines apiece and 2 spaces between them. So that's going to be what this video is about, but I thought I'd just give a super quick recap because that last video really focused on the primary key aspect of what I was doing with named tuples, but we also implemented a pretty spectacular caching system, which doesn't come off as an inaccessible cache. You can still access the data very easily. There's very little transparent magic going on. The files just, so the what, when, and wheres are immediately obvious. When the cache is working, it's plopping stuff into a cache subfolder of that repo, and you can see SEOML cache, and it's dropping its data into a namespace hyphen current date, and it continues that pattern, so you can always find where your caches are and they don't step on each other. And we use the standard library as much as possible, although SQLite dict is third party. We can still treat those caches as a real database in a pinch using real SQL syntax to get at that data and drivers. And we can always back-end it, swap off the back-end with high-end databases like Redis or Postgres in order to get high-end scalability and stuff. It doesn't really require a lot of SQL maintenance. We don't even need to think or talk in native SQL or even any of those ORM mappings. We're just talking in SQL. No, we're talking in Python dictionary language plus the context manager. And then easy enough that it can be part of every single project, easy enough and low enough overhead. And it's easy to prune, to make the snake eat its tail. So because of these dated directories, you could just delete a bunch of dates, and you could do that with an external script if you wanted to, and constantly make it so that your cache will never fill up your hard drive, and you don't have to talk SQL to delete out your cache. So we've got a really very awesome cache going on as a result of the project, which was primarily about primary keys. So every project has a cache of data where you forage in a folder from / with blobs of local storage. So we get back to the lambdas. We've got patterns we can look at to see how we're going to do this. It's always best to really build it up from scratch, but it's worth a glance at existing lambda, and you can see there's a variable-ish thing there, there's a variable-ish thing there. So I find these best to build it up as just simple statements, and then you turn it into a lambda afterwards. And anywhere where there's a variable, you put in a hardwired value is the way you typically do it. So if we were to pickle lambdaify these pickle functions, we hit B to get a cell below it, and it's returning pickle dumps some string. You're telling it a data type that's going in there. So what is some string? Well, the word string is some string, so that's valid. And now what we do is when you turn it into a lambda, you just say lambda, some arbitrary variable name, x, colon, and then you put that same variable name symmetrically on the right-hand side, and what you have is a function that you can actually call, and you can put stuff in there. So it's still the function. Yeah, it's being, yeah. This is probably being interpreted as part of the function. So you would go like that, and now like that, and that would call it. So this is the magic of Lambda. You can kind of see how I'm sort of zeroing in on getting this down from 2 lines to 1. We want to call that function pickle. So the function, we don't have to call the function anymore. We can get rid of the call to the function and the extra parentheses that sort of force it to be treated as a callable function, to force it to be able to be called with an open close parenthesis. I hope some of this makes sense. Lambdas are one of the weirdest, most mysterious things until you grok it. Realizing keywords like that don't mean anything. They're just symbols or syntax to trigger off certain behavior in the browser. And it's no harder than list comprehensions. You're just popping handles out and stuff. So without further ado, this is PKL. PKL is equal to that. And now we hit A for another cell above, and I can PKL any arbitrary string I put in there. And I've just created that same function that exists here on just one little line. And you can see how it's so tempting to put these in almost like configuration files near the top. And I'll finish this out and actually do that, because the unpickling simply becomes lambda x colon, and it's just as easy to retype it. There's this whole movement out there, do it once, DIY, do it, don't repeat yourself, DRY, the dry movement, big part of Ruby and stuff, but it's still silly. Pickle.loads. Oh my God, I repeated myself. Okay, so we've got 2 functions. We can test it, because this is pickled, and now we should be able to use the unpickle function to get the value out of it that was pickled. And there it is, the string comes back out. So this is as good as those. So why would you ever keep this? We just delete that. We take these 2 guys here, or girls, and we put it where other things look like it, little helper functions at the beginning. This is where I create the figlet function. So it's also where I create the pickle and unpickle function, and suddenly things become so much more easy and beautiful, right? So that's what we're trying for here. I'm trying to get my scaffolding stuff that I do on every project down to be easy, readable, grouping-like things, having as little redundancy as possible, adhering to PEP 8 as close as possible, and little shortcuts here and there that I do in order to just make it nicer to look at. So I could wrap this video up there, or I could go for broke here and try and show you this other project I had been working on down here that I sort of alluded to. And I think I'll do that. I'll make this a larger, more ambitious video. One of my favorite things to do is from headlines import asterisk. And after I do that, I would have functions like h1 I could call directly from inside these Jupyter blocks that would output pretty headlines and stuff, and I wouldn't have to have any sort of module name to do that. And you can see the advantages of that. It's much nicer to just type a very short h1, but to do this trick and then to have functions sitting around that construct your headlines is a violation of PEP 8. You don't want to do this sort of import. And then you have this external library that becomes a dependency. So wouldn't it be nice if you could do the same trick that I did here to get a bunch of headline functions in your main scope without being part of sub packages that have to be imported in this way? Because whenever you do this import, it establishes a namespace, and then everything you refer to in that, you have to do it from that namespace dot this or dot that, unless you do one of these from imports that gets it right down to the object you're interacting with. Then you don't have to use dot notation. That's the motivation for doing that. So I've got these really long, interesting regular expressions. And before I show you them, I'm going to show you some helper functions that are included with IPython, specifically the Markdown and the display function. I'm going to import them, and it's really easy to see what the Markdown function does. If you feed it Markdown, it emits it. Now the display function does some extra formatting to make sure it looks good in JupyterLab and Jupyter Notebooks, and it really comes out the same way. There's really no big difference when you wrap it for headlines. However, it's best practices to do it that way because you might be trying to display something that Jupyter should have a chance to come in and kind of fix it for itself. So first we turn it into Markdown using the Markdown function, and then we display. Now you have the background. I did a help on display to make sure I understood that it really needed to be included, what kind of stuff it was doing. And yeah, so I'm gonna put a lot of work into that for this exact use case. So I'm going to continue to use it. Now I'm going to build this thing up slowly because there's so much to it. We're displaying a particular thing here, and you remember the X for X in kind of concept of list comprehensions. I'm trying to think how to say it for Lambda. You definitely replace what was being displayed with a hard value with your variable, and then you go Lambda, same variable name, bam, and that just turns it into a function. And then you can give that function a name, which is doing the ironic thing of using an anonymous function maker. This makes anonymous functions. This has no name, really. And then to give it a name. It's a way of defining functions on one line. And you can see up here where I did that, I use mkd equals that function. So I now have something that can easily be used to display Markdown, right? So you'd think that's the end of the story. I just display Markdown and I use different numbers of hashtags depending on what kind of headline. Well, that's kind of annoying. That's totally not the API I want. I want H1, H2, H3, H4. And how many of them do I want? Well, you know, I would like range, let's say from 1 to 7. That gives you a range object. Okay, that's nice. But let's see. Yeah. So interesting how I built this up. There's different APIs that are kind of layered on each other here. And this is totally a case of things occupying the same different APIs occupying different syntax namespace, X for X in range. So whenever you have something that is list-like, you can use list comprehensions on it. So I now have the numerals 1 through 6 laid out by using list comprehensions against a range starting from 1 going through 7. We don't have the zero-based indexed issue, for example, there. And that was that outer square bracket. So I wrote this so I know what it is, and it violates some rules that Raymond Hediger talks about the human brain can hold about 7 pieces of data plus or minus 3. So I'm really pushing it on how much the brain can hold while processing this. But I just need to, rethink my thought process here. Instead of trying to analyze that and figure out what I'm doing, I know that I need this formatted as H1 through H6. So all we do is we use our string formatting technique that we learned about, where we can use the F outside of there and the curly brackets around our X. And now it's just strings, right? String replacement. Can you see what's coming? Put an H in there, and now you at least have your function names H1 through H6. Lambda. So it's a string. It's a string. You have the thing that's going to come before a lambda statement. You've got the left-hand side of a lambda statement. Now I'm about to build up this lambda statement that actually, one of my favorite things. These are a few of my favorite things. This thing right here is so satisfying. If I can just recreate it, because there's 2 versions of it. This is for when you're not in Jupyter Notebooks and you're just in Terminal, and it leaves out this mkd function. This one is for when you're in it. And so let's forget about the exec for a minute, which opens there and closes there. So that's what's executing, and you're executing turning this with a variable number. Yeah. Okay. So we're making a string, and we're carrying on that string, that tradition of making strings. You can see where it opens and where it closes. That's an awful big run right there. So that means that down here, I'm actually going to turn the single quotes into double quotes, because I'm sure I use those for some reason up there as double quotes. Oh, you can see how hard it is sometimes to get quotes to work right in JupyterLab. You can override that behavior in settings, but you can see it's doing the exact same thing. I just did single quotes for double quotes. And, H2 equals, because it's going to be the name of the function, and it's going to be the figlet thing we just made. It's not really figlet, but the mkd function, and it's going to be some number of asterisks before what we output. Okay, so first of all, you can see I'm doing something here, and I can show Markdown. If I were to put a string in there, there's our purpose for the single quotes. If I were to put, so it's not too big, 3 headlines, 3 hashes for an H3. Hello world, right? Now we could execute that string, and you would see those headlines be put out. So I give you a preview of the basic trick we're doing. Eval or execute? I use exec. Exec around that whole string, and there's a little preview of showing an H3 of hello world 7 times, right? That's not exactly what I'm going to do. I can also suppress those nones at the end with a semicolon there. This is so that you kind of get the idea of what I'm doing. I'm going to be using the exec function to execute the string values I'm building up here, which are currently just setting h1 equal to a particular markdown command. So these curly brackets let you switch between Python and strings. So we hit delete, we hit curly bracket, and we put the asterisk times x. Where's x coming from? X for x in. That's an x. That's that number. So now you have a different number of hashes before the hello world, right? Now you're seeing a number of individual statements that are each themselves candidates for becoming a new Lambda function. And we already have the unique names set up there for that. So all we have to do is go inside that string. And remember, we already used the x for x in trick of the list comprehensions. This is primarily a list comprehension. There's nothing Lambda about it yet. And the x for x in belongs to the list-like object that exists there. We're going to replace hello world with a string replacement that will come from elsewhere. Okay, where is that elsewhere? It is outside the string definition as, no, I'm sorry, that's inside the string definition as lambda y colon, name y is not defined because I'm attempting to use y there already. So that's not right. Let me see. Yeah, except for the fact that this won't, this will actually show the y. So we look over here, I have a little bit, lambda x for x in. Oh, I don't keep the x's and y's separate. That's pretty nuts the way I did it here in my first sample. But I can see how I'm doing it. The hash is inside the string, and oh, %s, yeah, %sx, and just copying it back over that way into. This is so fun and interesting. So the challenge here is that Lambda is going to be providing a y, but y is not particularly executed yet, but we want to be sitting in there in the string, inside the string, ready to be replaced. It's going to be a %s, and the y is going to be here. Lambda y colon h1 the %s comes from the right, and this is eerily close to what we want. I can try and execute each of these statements, and we look at what's inside the double quotes to evaluate it for executability. We're looking for the correct opening, closing of parentheses, the correct kind of intent, and it does in fact all look quite solid to me. So I'm going to try putting the exec here and here. cannot assign to lambda. Let's see the difference between there and the examples I created. Yeah, cannot assign to lambda, comma, globals. Is that the only thing I left off? It's probably globals. Cannot assign to lambda. Make sure you got the right thing there. Oh, I put the exec in the wrong place. Oh, I use one more list comprehension to actually execute these things. I can't. Yeah. So this is a list. See, this is a list. And now I've used X and Y, and I'm now going to go Z for Z in, and it's going to be X is not defined. Yeah, if you do one more list comprehension, you have to actually do your nested list. Z for Z in. Okay, it seems like it's the exact same thing, right? But what you've really done is you've lifted up sort of this accessibility, this line-by-line accessibility. So now I can just, well, first of all, I should probably do a before and after. There is no H1 function right now. I don't think so, right? It's just not there. It's not defined. Nor is there an H2 function. And so on through H6, but there should be, if I execute each of these statements. Cannot assign to lambda. All right, but it's highly readable now. Lambda y colon. Oh, yeah. I got my syntax and my terminology a little bit confused. You can't assign H1 equals lambda y. H1, I have just the location of the H1 equals wrong. So this goes out to here, changes a statement a little, right? Makes sense more according to how we've been thinking about these things. And now I should be able to execute each of these. Wow, what a video. Okay, and it's got the none. That's the suppression that we can put in there. And now we should have a hello. No, we don't. H1 is not defined. Oh, and that is that final piece then. It's got to live in the globals. This is a parameter that's just got to be added. And that is a parameter of exec that belongs to exec. And you can see I took a slightly different approach up here than down here, but the net result should be exactly the same thing. Hello world. Oh, yes. Let's see if it's a shorter line or a longer line. It's about the same. So this is the one that works for Jupyter because it's got this command in there. This is the one that's almost the same thing, but it works for just when you're in the normal Python shell because you're not going to have access to the things that get imported to make it work. So now, finally, this import is an import that we're not going to want to do unless you're actually in Jupyter so it goes here as opposed to the traditional location of doing imports. We also are going to want to have all those headlines, H1 through H7, accessible to us if we're in Jupyter. Major PEP 8 violations here. However, we'll talk about those later. As soon as I turn on that black linter up top, it's going to do all sorts of indents on this thing, which maybe it should for the sake of readability. But we do want to have the other version in here as well, which is pretty easy to just modify from it, because all it's going to do is not feed things through the MKD function. So you get rid of that, get rid of the parenthesis over there, and otherwise it's pretty much identical. You're going to just emit the number of asterisk of hash symbols without actually formatting it into an H1. So I should be able to execute that. And let's see. Let's get rid of our extra stuff now. This was for demonstration. This was the old example. This is to show you the spirit of what I was doing, because headlines are useful. That's that import. That's get rid of all our work. And now we're back to a nice clean place again, but now I have headlines that are built in and always available to me. It doesn't require an import, and I'm going to restart kernel and clear all outputs. I just do this one, and now I can show you how I like to use these headline functions. After they exist, I can start using them immediately. I would use it right here. H1, set up global, resources. And then I would put an H2 at the bottom, usually going done. MKD is not defined. Okay, so I did get rid of that, didn't I? That's not too hard to make up again. It's one of these types of lines that doesn't need to happen unless it's in here, and we know that MKD is equal to the use of the lambda to make a one-line function, and it's going to be an arbitrary variable. It really doesn't matter at this point. I think I'm going to use A to start at a different side of the alphabet, and you use these import things you just imported. Display goes around Markdown because it knows how to handle Markdown. Display, Markdown, the variable name you just decided to use. So now that we have that, you've got your set up global resources. Let me do some ellipsis, and I'll do exclamation point. And now I have an H1, H2. I put the H1 at the bottom of this because it gets created so long in the process. But whenever you're doing anything else, you can say, H1 set up optional Google credentials. Now you got to print, because it's not going to be the last line on the thing, H2, done. And that's the pattern I like to use everywhere. A headline to tell me what each code block is doing, and a done. And the nature of these things just magically transforms. I'm not going to do the whole mbdev package release thing, but instead of showing as headlines, it's going to show up as single hashtag this, double hashtag this. So it's good for searching in log files and stuff if you've got a system that automatically captures the output of your program to log files and such, which I do. We'll be getting to that later. It makes searching for headlines and subheads easy, and all the niceties that you put in for yourself in Jupyter Notebook and Labs have kind of another life for them in those logging, in grepping your log files and viewing your log files scrolling by you in a screen terminal, all kinds of fun stuff. So there you have it. This was a longer video than I anticipated, but I wanted to show you how to make nice, clean, one-line Lambda functions so you can sprinkle them in as a matter of style and cut down on all that extra vertical lines usage and indenting that's it's not really necessary. This is a great way to go. And as a bonus, I made my H1 through H7s that are always there and available for you, that you can decorate your notebook with, your code blocks, and which will be just fine in the official python.py packages that'll be output by NBDev. Thanks for joining me. Hope to see you again soon. And don't forget to subscribe.